In this video, we'll learn about proportions. Proportions are two equal ratios. So if I have something like 3/4 and I have another fraction, let's say it is 9/12, you can look at those and you could tell that they are equal to each other. Another example of a proportion would be something like 10/20 and 400 800s, right? Those two are equal to each other. But one of the interesting things about two fractions or two ratios that are equal to each other that form a proportion is if you take their cross products, 12 times 3 is 36, and 4 times 9, also 36. If you have a proportion, the cross products are equal to each other. And we're going to see how we can use that to help us solve a proportion. So over here on the left is an example of a proportion that we'd like to solve. I want to know what k is. I know these two ratios are equal to each other. So I could use that cross products property to solve this proportion. I know 2 times k is equal to 9 times 25. And now I just want to solve this for k. So I'm going to divide both sides by 2. And I find out that k is equal to 112.5. So what are we saying? We're saying 9 over 2 is equal to 112.5 over 25. Now, does that make sense? 9 over 2. Well, if I think about 9 over 2, I know that that's 4.5. 112.5 over 25. Well, 25 goes into 112.5 4 times with half left over. They're both equal to 4.5. All right, try to solve this next proportion. I'm going to use the cross products. 5 times 11 is 55, and that's going to be equal to p times 9. To isolate p, I'm going to divide both sides by 9. P is equal to 55 over 9. Well, I know 9 goes into 55 6 times with 1/9 left over. 1/9 is equal to 0.1 repeating, so 6.11, that's the rounded answer. All right, now let's take a look at this proportion here. I want to figure out what b is. What is the value for b that's going to make both of these ratios equal to each other? I'm going to use that cross products property. 4 times the quantity b minus 8. So it's not going to be 4b minus 8, right? I'm going to multiply 4 times that whole quantity. And then 5 times that quantity b plus 3. You've seen problems like this before. You know what to do. Let's distribute the 4 over on the left. 4b minus 32 equals 5b plus 15. I want to isolate my variable, so I'm going to subtract 4b on this side so I can keep that coefficient positive. Then I'm going to subtract 15 from the left side to get the variable term all by itself. Well, what do I find out here? I find out that negative 32 minus 15, that's negative 47. And that's going to be equal to b. So what does that mean? That means negative 47 minus 8 over 5 is equal to negative 47 plus 3 over 4. So negative 47 minus 8, that's negative 55 over 5. Is that equal to negative 47 plus 3? That's negative 44 over 4. Absolutely. Both of these are equal to negative 11. All right, here's one for you to try on your own. Take the cross products of your proportion here. 10 times this quantity, n, plus 1. That's going to be equal to 2n. And now distribute. 10 times the quantity n plus 1 is 10n plus 10 equals 2n. Well, I've got only the constant on the left side, so let me get rid of the variable term that's on that left side. 10n minus 10n is just 0n, so I'm left with 10 on the left equals negative 8n. Divide both sides by negative 8, and I get negative 5 over 4 is equal to n. That is D, negative 1.25. And now let's see how we could apply proportions. I want to be able to write a proportion for this problem. An 8-ounce can of orange juice has 97 milligrams of vitamin C. How many milligrams of vitamin C are there in a 12-ounce can? And here's a great hint. Think about what units are being compared. So we can use proportional reasoning to solve this proportion here. I've got 8 ounces of orange juice. It has 97 milligrams of vitamin C. So if on the left side of my proportion I'm comparing ounces to milligrams, then I better compare the same thing on the right side, ounces to milligrams. So how many milligrams are there in a 12-ounce can? 12 ounces in my numerator and my variables in my denominator. So to solve this proportion, I am going to cross multiply. 97 times 12 is 1,164. And then 8 times x is just 8x. I'm going to divide both sides by 8. And I'm going to find out that x is equal to 145.5 milligrams. Let's see if that makes sense. In 8 ounces, there's 97 milligrams. 12 ounces, 145.5 milligrams. Yep, that is logical. All right, here's one for you to try on your own. Remember, you want to keep the units consistent. So when I look at this problem here, a frame is 30 inches wide and 18 inches tall. If it is reduced to a height of 3 inches, then how wide will it be? I'm comparing the width to the height. So I want to do the same thing to both sides, the width and the height. And this helps me set up my proportion the right way. So a frame's 30 inches wide, 18 inches tall. If it's reduced to a height of 3 inches, how wide will it be? This is my unknown. Well, I can cross multiply. 30 times 3 is 90 equals 18y. How many times will 18 go into 90? It'll go in 5 times. So 5 inches is the width. But did you notice on this problem, 18 divided by 6 is equal to 3? So you could have just seen that 30 divided by 6, that's how I get 5. So our answer was C. And that is how we solve proportions.